Welcome to my discussion of Postgres database and EMET 5.0. My name is Jacob Gore. This is for the class ISA 4220, the spring semester of 2016. Enhanced Mitigation Security Toolkit, or EMET 5.0, 64-bit is what we'll be discussing. EMET strengthens the security of non-Microsoft applications by using defenses built within Windows. I guess to first notify you is that EMET is built for the Microsoft or Windows operating system. Examples of this or how this does this, I guess better to say, is it uses address space layout randomization and data execution preventions. ASLR, or address space layout randomization, randomizes the locations of applications and files in your system's memory so an attacker can't create reliable exploits that need to know where certain files and code is. That's pretty explanatory. An exploit will use certain paths or certain executables, and we'll have to direct or find that. If those executables or those exploits can't find those files, then it's basically not going to be able to work. Data execution preventions, DEP, allow the system to mark specific sections of memory as non-executable data. 5.0, attack surface reduction. It's a mechanism to block the usage of a specific module or plugin within an application. An example of this would be prevent Microsoft Word from loading Adobe Flash Player plugins to create an exploit. Export Address Table Filtering Plus, EAF Plus, is a protection against advanced attacks by hardening low-level modules from attacks targeting build return oriented programming, ROP, return oriented programming, gadgets in memory. There have been some concerns and some vulnerabilities for 5.0. I'm still going to continue with 5.0, but likelihood when we're moving to 5.1. And also he uses deep hooks. This mitigation feature is effective against advanced exploits using RLP gadgets with low-level APIs. Some of the best practices for when installing, use Windows recommended settings. Once you do the recommended settings, you're going to increase the security. And through custom configurations. Some of the custom configurations or how it's set up in Windows is it's done through client side and server side. Client side attacks prevent applications on your server from being used from remote code execution, and the server side, any service protocols or ports that are often subject to attacks. Here's the how-to to install EMET 5.0. When installing EMET 5.0, there will be a wizard that pops up. This wizard is on. You should be familiar with this if you're familiar with Windows. There's pretty much a wizard for everything in the GUI. This will guide you through the process and select the recommended. First you'll go through it. It'll ask you to accept a term of agreements. It'll give you a path, file, folder designation. Just accept that, and then select the recommended settings once you get to that page, and allow the install to happen. So click on Finish Install. In the System Status section of the EMET, after it installs, you'll open the EMET, and in the System Status section of EMET, make sure DEP is set to Always On, SEHOP to Always On, ASLR to Application Opt-in. In the Quick Profile Name field, have it set to maximum security settings. That's where you're increasing the security settings. Select the Apps icon, which will be in the upper left-hand corner. In the mitigation section, this will actually be in the upper right-hand corner of the Apps field of the Apps page. So you're going to select the Apps icon that's going to a new field. In the mitigation section, up on the top right, make sure deep hooks, anti-detours, and banned functions have a check mark beside them in that little box. You also in the next section over from the far right, so the second section from the right, and the default action section is going to be called default action in the bottom. The stop and exploit should be selected. So stop and exploit should be selected, not audit. Audit is useful if you want to troubleshoot or see what's going on, but stop and exploit is what you should have selected if you want this to be running fully. Custom configuration for EMET. In the same window, click on Add Applications. This is going to be in the upper left corner. It's going to be a big green button. Add Applications. It's going to have a plus sign in the middle. It should be upper left corner. I don't know why I put upper right corner, but here all you need to do is point EMET to the application you want to protect. So there will be a list. Once you click on it, you'll click on the application you want to protect. Now go back on the EMET home screen. Under running processes is a list of all running processes. So find running processes, select that. It'll show you a list of all the running processes. Then you want to look through the list and figure out what process you want to select. An example of this is IIS. We're going to have IIS on our system. It's going to be for the web server and SMTP for our server. So we're going to right click on that executable and select configure process. Once you've done that, it'll go through there and that process will be protected. Alright, now into Postgres and database technical discussion. First, to go over what Postgres is. Postgres is an object relational database management system, ORDBMS. It supports a large part of the SQL standard and offers many modern features. ORDBMS, Object Relational Database Management System, is a database management system that has an object-oriented database model. What that means is, in object-oriented, everything's treated like an object. It's modularized, it's easy, it's more secure. To go on, it supports objects, classes, and inheritance in the database schemas and query language. Schemas is the tables, how it's laid out. The main feature of ORDBMS is allows users to define data types, functions, and operations. It allows for inheritance. So if you create a data type, you can derive new subtypes from that, or subclasses, which would therefore inherit all attributes and methods from the parent type. That makes it simpler if you want to create, let's say, a main accounting department, and you have two different accounting departments. You have accounting for some branch over here and a branch over there. You could use those two. You could put those two accounting departments under that larger accounting type, and they would all inherit that. Method encapsulation. Methods are procedures or functions that can be encapsulated within defined objects so that applications can use to perform operations on the attributes of the object type. Methods are optional. They define the behavior of that object of that type. So basically you can control objects and how those attributes are used and how they're continuously used, so you can bring about methods constantly. Alright, let's go over how I query, the stages the query must pass to get a result. A query is basically, it's a query. It's you're asking the database to do something for you, to input something, to output something, to add, delete, whatever. Alright, so to do a query, here's what has to go. First, a connection between the application that is submitting the query, whatever, and the Postgres server must be established. Then, the parser stage confirms that the syntax is correct and creates a syntax tree. The rewrite system takes the query tree and looks for rules to apply to the query tree. It performs the transformations given in the rules bodies. The planner/optimizer takes a rewritten query tree and creates a query plan that will be the input to the executor. The executor recursively steps through the plan tree and retrieves rows in the way represented by the plan. The executor makes use of the storage system while scanning relations, performs sorts and joins evaluates qualifications, and finally hands back the rows derived. And then you're done. You got your results, what you wanted to from the query, or the application did. There's more to it. There's more. You can actually get more in depth in the parser, the rewrite system, planner, optimizer. All those have steps within them. Well, this is a basic overview of how a query goes about and how you get your result from it. Alright, so some of the best practices for Postgres specifically are to remove all trust lines from the PG hba.config file. The reason why you want to do this is on the server that we're using is going to be at one host. So we're kind of be going off host-based or role-based access. And you don't want just any user being able to use your database, your Postgres database from the outside. If an attacker is able to get into a user or something like that, you don't want them to be able to change or use your database. So remove those all, allow all, stuff like that from the PGA. Add per host lines for each application host to use. Allow only necessary users to have network access from necessary network segments. That doesn't pertain so much to this, but it's still a good practice. It's pretty much saying you don't want anybody else being able to use access from your necessary. So in our setup, there's actually going to be other people who are having this. You don't want them to be able to use yours. Allowing users and network segments to connect only to the database that they need access to. Avoid using all whenever possible. Use MD5 as a method for comparing hashes across the wire. MD5 is allows you to authenticate and hash your passwords. Add default at all .0.0.0 reject rule at the bottom of the file. This will reject anything else that you don't want. Postgres uses a top-down as opposed to others like a firewall where you want to deny all first. Here you're going to deny all at the end. You're going to set up what you want first, and then you're going to deny everything else. Provide Postgres service account only to those who need access to control the Postgres process on the system, and only after they have authenticated to the box using their own account. For CentOS, you would use sudo. So the administrator would sudo into su and then use whatever. Ensure PG HPA allow only the required database accounts to have database login from the local Unix sockets. My references. There's another page for my references.